welcome back to becoming a ROS developer here at The Construct. My name is Rodrigo. You might have seen me literally like 3 minutes ago because we were doing another presentation, but hey, the learning never stops here. So today we have one of our students, Tolga Delice, who has completed his ROS 2 basics in in 5 days. Sorry, and he has completed the course, and now he wants to present his real robot project, in which he's going to show us the main takeaways of the course applied to an actual real robot. So, hello, Tolga. How are you?
Hi, good. And you?
I am very, very good. This is actually not the first time we meet. We saw each other on Tuesday. We were actually in the middle of recording and this presentation when the power went out in the headquarters of the construct. So I wanted to apologize for the little inconvenience you had there,
Uh,
and hopefully with the extra practice, it'll be extra nice your presentation.
I actually studied the presentation a little bit more.
Well, nice, nice. Well, anyways, Tolga, just to let whenever you want, you can start sharing your screen and show us what you've done.
Okay, let me share it. How does my screen show?
Yes, I can see your screen now with the robots and the
Okay.
terminal.
First, I started a bridge to ROS 1 to ROS 2 because the robot actually working on the noetic
Mm-hmm.
ROS 1. And I will now start my uh, main function with this. The robot will find the shortest uh, laser, and it's it takes its index, and according to that index it will turn left or right because of the efficiency.
Nice.
And after it's come closer to the wall for I think it was 30 centimeters, it turns its right to it, and after it turns it right to it, the odometry value actually takes that position and saves it because it needs to check if the lab is completed or not.
Mm-hmm.
And after it started, we can see here both the total distance and also distance from robot to the starting position.
Oh, I see. For your
Uh,
stopping mechanism or something.
yes, I
Yeah.
actually couldn't make it to work for 5 centimeter uh, const, uh, in every time, so that I increased it little bit for uh, 15 centimeter.
Okay. Okay. Yeah, mungkin beda baik,
And
but yeah.
for the uh, wall following, I used it like if the right laser is so close to the wall, it will turn right, and if it's too far away, it will turn right. But I also add a little bit of feedback. If the previous cycle's right signal is minus, the current signal is minus,
Uh-huh.
uh, I might confuse it here, it there, but I will explain it in detail in code.
Great, great.
It will. It's a simple feedback. If it's negative, that means it is going away from the wall,
From the
so we
wall.
don't need to add additional turning velocity. And I think here is, let me stop the robot first. In here, we can see all the odometry values it's collected
That were collected. Awesome.
for the lab.
So you added an extra efficiency for
Yes,
to avoid sending extra uh, negative angular velocities when it's already going that way.
yes.
Great. That's
Uh,
nice.
and
Awesome.
it will be easier to explain in the code actually.
Please let's look at your code because
And
now we saw that your project works really nicely. So let's look at how you actually solved it.
and actually for the uh, wall finding method, I first did it in a different way. Uh,
Okay.
we see here three different uh, reentrant callback groups in
Uh,
order to use different uh, callback groups in the same time for multi-threading.
right. Let me interrupt you right
Uh,
here because you can actually do this. I mean, it's fine. This isn't wrong, but well, it's inefficient because you can actually do it with only one group.
yes, I know. I will tell that why did I use it, because I
Great.
wanted to test how
Yes.
many uh, group I can use at the same
At the
time.
same time, that's nice.
It it has three here and two here,
Uh
and
huh.
for the odometry also two here. And actually, if these all of them works together, if I don't shut down the wall finder,
Uh huh.
uh, when sending the velocity data, sometimes it doesn't get the uh,
The data in
CND
time.
value and goes straight to the wall.
Right. Yeah, because there's too many things going on. So and
Yeah,
then the scan callback, which is when one of the groups might have not updated correctly. So then it's still saying, I'm still 40 centimeters away. So the
yes,
next
I
time it
wanted to
checks,
test it.
it's like already crashing into it.
I
Oh,
actually
that's
wanted to test
interesting.
it.
That's interesting. Yeah, yeah. Um,
uh, there are
what?
some global values here, and the other version for wall finding was I was calculating it with if the I from the IDX value I will uh, get the how much should the robot turn
Rotate and then do it with the odometry.
and do it with the odometry. It was worked fine in simulation, but in real robot I couldn't make it work in one session, so I need to try
I
more.
actually, this is funny that you mentioned this because by any chance, were you asking about the Z value in the forum in the real robot? The,
You
no?
no, I didn't, but I saw it, and after checking it with the in the robot, I actually saw the different. There's a little bit of a problem with the odometer values. I
Oh,
wasn't sure
yeah.
it was the Z value, but
Well, it was the yaw. Apparently, and I have to look at this because it might be right because the robot's old, a little bit old, and IMUs fail and everything. So I think there's a little bit too much noise. And there's something going on maybe in that Z angular yaw measurement of the odometry because we saw that the X and Y works really well because that's what you use to go around, and detect how long you've gone and print it out. That works really. That works, but there's something that is being now that you mention it, you're the second person now, so I'm gonna take a look because it might be an erroneous. It might be a sensor that's out of whack, and that's why it wasn't working in the real robot.
actually I tried to troubleshoot it with looking at the topic info and
Great,
other things,
great
but
idea.
I actually couldn't find what was causing that error. But I think some of the time the reading uh, in the simulation it wasn't zero for Z value, and it was zero in the real robot. But it was just
Uh,
sometimes, not always.
well, you also have this XYZW. That's a quaternion. It's not
Yeah,
a and it's an Euler angle. So I mean, I can't understand how quaternions like the showing. But something you can do for this, another way of testing it, which is probably what I'm gonna do, is just open, connect to the robot and then just open RViz, and you can add the odometry to RViz as a topic, and you will see like it's an arrow, so it's just pointing towards where the robot is going. And if there's a problem with the orientation in the Z axis, you would see this arrow not stay still, basically.
ah,
So that's one way, another way of doing it, which is avoids, kind of like printing things in the terminal. So that's another way. And I always wanted to remind people, RVist is just such a good tool that we sometimes don't think about until it's like 2 hours into our problem. We're like, oh man, I should have done this first. So yes, I think it might be a problem, but it's nice to set that you see that I see that you have two methods then, and this will work. This will work because you're doing it with the simulation and it works, and you're looking at the odometry, how much left you have to turn. So this is perfectly valid.
I actually made a mistake here at first because on the robot, how the front laser is sometimes 108 and sometimes it is 360.
Oh, and sometimes it doesn't have even 360 vision.
And
Sometimes it
I
has less
was
valleys. Yes, yes.
and I was calculating the IDX index to the degree from the zero.
Right.
So I needed to rotate it uh, and half a pi to make it actually work.
Hmm.
There is also that I solved this problem for that method in the simulation
Hmm.
also. And in this code, there is there is a flag for the task being finished, and this will raise an system exit, and it will exit here and shut down all the node.
Oh, nice. There.
That will we can free the unnecessary three other threads
Uh huh.
in order to other parts of the robot to use it. That's why it's working
Great. Oh, I
better.
see. I see. So I never actually
And
seen that system exit being used. It's nice.
I actually not sure if it's going to work in Python. We can raise exceptions, so I tried to use it as an exception, and it actually worked.
There you go.
Uh,
And then you get rid of
and
those extra callback groups that might be getting in the way for the rest.
yes, since I'm not going to use the wall finder again, the one thing I could do is adding the CRV to feedback and get the laser callbacks from here and not shut
Right.
down wall
That
finder.
actually is a great idea because you're saying change the service server to an action server and get feedback. Is that what you're
Yes,
saying? Yeah. And besides, you don't have to wait until the result because when you call a service, you have to wait. Your program has to wait until it either fails or succeeds. And with an action server, like you saw, you can keep going and do things with it while the action is still going on. So that's a really good idea. And then you have more information, and it helps you debug better. Yes.
yes. Now I will continue with the wall following. Uh, in the wall following, here are the I created the publishers and subscribers and the client here.
Mm-hmm.
Some time I used a timer callback group because of the main function would work better in the timer group.
I see.
Uh, and here I want to show the thing I did with the control. There is a laser right control uh, data. It's calculates here. Uh, it sends to the temporary write control, and it keeps it for one cycle, and the control, this will cause the value of the write control to be before one cycle ago.
Uh
With
huh.
this, we can say if the robot is going away from the uh,
From the
wall
wall or
or
towards the wall?
towards the wall. And actually, when I talked about it, I did see a mistake. Now, I should have done a search from, for example, if the right laser is 180, from 220 or 233 to 100 10 to find the shortest ray in that, because when the robot turns like right, the 108 isn't the shortest ray.
Right. Not
There is
anymore.
actually a little bit of a mistake here, and I can use the index value to and the PD controller to
There you
make
go.
it
That was what I was
better
gonna say.
actually.
You'll see that this is good because you're making yourself think like further of, hey, but what if this happens? Then I'm gonna create a condition for that. But you'll see most of these things go away when you start doing like little simple PDs and things like that. So
I actually want to challenge myself to have a control without using PD, because in school I used so many times.
right.
So this is more challenging for me actually.
Oh, okay. Well, then there you go. That's the first time I hear that, but that's great. That's great.
And the this is the there is a actually there is also, I call the wall finder with a not a asynchronous call but a normal call, because I wanted the main function to wait for that call to end in here.
Mm.
Uh, that's all. That's about all of it in wall following, I guess.
You got 5 more minutes, by the way.
Okay, for the odometry recorder, I have two callback groups. One of them is checks the uh, lab, and the other one takes I actually use two of these in one callback group,
Mm-hmm.
because in while cycle, I also continue to take more odometry values, so I need
Right, of course.
just two in here, and I actually make it 10 centimeter. And I also added a length to the odom recorder to be more than 40, because when it first started, it will say the lab finished
Yeah, right,
otherwise.
because it's in that zone. So, yeah, yeah.
The
And there's
other
many
solution,
ways of doing this
yeah,
too.
the
But
other thing is I could make a flag for it to uh, get away from like 50 centimeter from the start, and after that start checking it,
right.
uh, and uh, it calculates the distance with the uh, here here is the formula for that I used here. It appends the list here for the latest odometer value,
Mm-hmm.
and it's continuing like that. The one problem I had and I didn't quite understand was I actually first used mutually exclusive callback groups here, and it worked in simulation, but in real robot, the it stuck in turning actually. I didn't quite know its reason,
Why?
and
I think it will be because the it stayed turning, and then eventually it would kind of get unstuck, or it just stayed turning forever.
it just get unstuck sometimes,
Right,
but not
and
always.
not always. And the reason is because since you weren't using an exclusive callback group. So think about it like this: when you do this group, these callback groups, you can you can run two callbacks or more. I don't know how many you can shove into one group. I've never tried it, but that way, you'll have your scan callback running in one side, and that will get updated every time. And then you'll have in here your execute, for example. So what happened, I bet, was that your scan callback wasn't getting any values because he was being blocked. So the program thought, well, my command is to keep turning until something in the scan becomes something, and that never happened because you weren't getting new values. And I think that might be the reason. Of course, I would need to
Ah,
look at it, but that's the reason why, if you try to do this, I don't know if you've tried it in ROS1, but in ROS1 you don't need to have that because reentrant in Python. In C++, you do. But yes, this is to avoid that precisely.
Ah,
To avoid a callback not getting the information it needs because the program is busy doing something else.
I I understand,
Right.
and it's also writes that in the uh, documentation actually
Oh, nice.
about the uh, multi-threaded executor. It could block the other function,
Yeah, and it's
other callback
random.
groups sometimes.
It's not random. It's according to like low level
Uh, yeah,
PC unit
it's about
memory
to do with the
management.
cycle and cycles being hurt, uh,
Right, which
cycles being together. Uh, uh,
exactly, which I don't really understand. I don't need to, so I'll just stay before that, you know. So, but yes, yes, yes.
and the one last problem I got was uh, when I first make it work, it actually sometimes couldn't send uh, CMD publisher to the data. Uh, Actually, adding a sleep time here and some other places solved that, but I don't actually why it caused that problem
Uh,
too.
so
But
you're
I'm
saying it
guessing
wouldn't stop?
it wouldn't stop at the time it should. It would stop half a second later, 2 seconds later, 5 seconds later. But after adding a little bit of delay, it worked flawlessly,
Huh.
interestingly. But I think it's about to do with the Q of the CMD value in here, actually.
It could be, yeah, but this sounds like more specific to your application, you know. So I'd have to look at it closely. But something I did notice
Uh,
is that you have a callback group for a publisher. You actually don't need that. I'm
ah,
actually surprised to let
I,
you include it because a publisher doesn't have a callback, right? Because a
I actually
subscriber
added
needs.
while trying to solve the problem I previously describing.
Right.
Oh, it's interesting. So I don't actually not really need this. I
No,
don't
you
even
don't
need to
need
test
three. I
it.
mean, you only need one. You can
Actually,
make
yeah.
everything work with one. But the
But since
publisher,
I learned in the course how to use multi-threaded function, so I wanted to use it.
absolutely, yeah, yeah, I understand. But just so you know, no callback group in subscribe in publishers.
Yes. And actually, now I think about it, it would be better if I just do in here like there is a timer callback group. I could use a timer callback group here, and
Hmm.
in that I could solve everything probably
You could, but I mean,
most
you
of
still
them.
need it. You still might need it in other places. It's not necessary that you. Yeah, yeah, but you're right. Yes. Um,
But that's about all the problems and things I solved and I did about the project actually.
all right. Well,
I'm not. Should I also explain the uh, interfaces? I don't really think I need, but
no, not really, because I mean, yes. Tell me
I
what that
just
is. Tell me what that is.
uh,
What you just opened.
for for the wolf finding wolf a client to send a value to the subscriber that I found the wolf. We need the CRV data to use as a messenger. I
Right, right.
call it messenger, but
Because
not
when you
the
call the
anchor.
service, You wanted to send nothing, right? And that's why the line
Yes.
one is empty, and then you want just a true or false.
Yes. If
My
I wanted to add a feedback, I can add here, but it's more like
Well, you
being a
can't have
CRC.
feedback in
Yeah.
services. You
Yeah.
mean the
It
action.
becomes action
Yes.
client.
So let's look at the action
Yeah.
message, for example, and we'll see what we're talking about.
It's here.
Right there. So that you have that feedback. Again, you don't have a request, but you could say, like,
Yes.
I don't know, two versions of two inputs you can shove in, find the wall turning left, find the wall turning right, or something like that. And yeah, yes, I mean,
And
you need this because there's no standard messages that can accomplish this.
yes. And this way we create another interface to send messages and get messages actually. We don't send messages here, but we only get it. And that's
Well,
about
you are
it.
sending messages. You're just sending an empty one.
Empty message.
Yes. Yeah, but
That's
the,
right.
the message is being sent.
Yes.
All right. Well, nice, Tolga. Do you mind stopping sharing your screen so we can look at each other?
Yes, sure.
All right. Well, congratulations, Tolga. Really nice.
Thank you.
Really nice project. I like how you experimented with the multi-threaded executors. But remember to always try and keep your code as efficient as you can. Just the way that you did, the same way that you did. It's gonna turn right if it's gonna be closer, than turning left when it's finding the wall. Same thing with the logic of your programs. So you have, I struggle with this all the time. So but yes, just keep that in mind that you want to leave them as light way as possible, just for as good practice. And I really like how you also did the system exit, for example, that exception. That's really nice. And I'm surprised also that you talked about how it was, you work a lot in school with controllers. So I encourage you, please use them because I think I'm lacking knowledge in that. Well, I did some in school too, but a long time ago. But I think it's interesting, and I think it pushes the boundaries of what you can do with control.
It's actually funny because I know how to calculate them and find the necessary values.
Mm-hmm.
But
putting into code is like
putting into code is a different thing.
Right, absolutely. Then writing the
I
equation.
didn't learn coding at all in school.
I see.
So
I'm exactly the same. You probably are a mechanical engineer or something, huh?
I'm actually a mechatronics engineer.
There you go. It's the same. Yeah. I'm in the same boat as you. But yes, you'll find some templates online, especially for Python. You'll find templates, and then you know how crazy the control loops get. So you'll get like the simple one. But
I actually wanted to use a fuzzy controller in here.
Oh, that'd be. Please, try it for your next course and show it. And
I'm gonna. I thought that I will try those in navigation course.
There you go.
I actually started today.
Nice. Well, I'm excited to see what you do for that. But again, Tolga, congratulations. Really nice project. And
thank you.
Yeah. All right, guys. We're going to end here our video for our second presentation of the day. Remember, you can do what Tolga did here to obtain a certificate and get the most out of your learning experience in the construct. And Tolga, thank you very much, and hope to see you again soon.
Thank you. Have a good day.
Have a good day too. Goodbye, you guys.
Bye.
All right, we're done.